Hello and welcome to 5 Minutes of Postgres. My name is Lucas and today we're going to talk about unlocked tables in Postgres and whether you can recover them after a crash. Now, first of all, we'll start with this blog post by Greg Sabino-Milani on the Crunchy Data blog. Now here, Greg describes how when he's working with customers at Crunchy Data, sometimes customers add unlocked tables. And he's going to describe the different trade-offs. And I personally don't use unlocked tables much, but I do think they can be quite useful to have in your arsenal of tools when working with Postgres. So first of all, the choice you can make is on a per table basis, whether a particular table can be unlocked or not. Default is that tables are logged. Now, logged means that they're written to the Postgres wall and they're persisted that way. So it's a durability choice you're making here. Now, an unlocked table will give you massive improvements on write performance, as Greg describes later in this post. They will also reduce the vacuum impact because vacuum writes changes to the Postgres wall stream. Doesn't have to do that for an unlocked table. And they generate less total wall, which leads to less wall traffic, faster replication for other tables, smaller backups, and such. So there's reasons to use them. Now, reasons to not use them is that unlocked tables are truncated on crash recovery. So that means if your Postgres server crashes, you lose the data in an unlocked table. It's gone. Now, you can also only access this data on the primary, not on replicas. And that's because an unlocked table isn't in the wall stream, and so the data wouldn't show up on the replica. The same applies to logical replication, because logical replication underneath the hood looks at the wall files to get the data for replication. Unlocked tables are just simply not present there. So there is a trade-off here. The first thing that Greg does here to look at how much of a benefit they are is he runs a pgbench. He also turns off auto vacuum when running this pgbench. And don't turn off auto vacuum on your production system. That's a bad idea. But on a pgbench, it can make sense because it reduces variability because pgbench doesn't have an auto vacuum that interrupts its workload. Here, we're doing a table with 1 million rows, and then we're updating those 1 million rows. This is with a locked table by default, and it takes 5.6 seconds to run. That's a very short benchmark, but I think it shows the point, which is here in this case, we're generating 320 megabytes of wall. When we're rerunning this same test, we can use the unlock option to pgbench, which makes the pgbench tables unlocked. You can see that now it takes 3.1 seconds to run. It's almost twice as fast to run the benchmark. And more importantly, you can see that the wall that was generated is a mere 16 megabytes, a single wall segment, instead of the 320 megabytes we saw earlier. Greg also looks at the pgbench numbers here. We can see with the transactions per second, if we run the regular log table, it's 168 transactions per second, whereas an unlocked table is 485 transactions per second. Much faster to run the pgbench with an unlocked table. Now, why wouldn't we always want to do that? Really, the main thing to know about unlocked tables is that they're not persistent. You essentially should expect your data to be gone. The one exception to this is when you have a clean shutdown. When you have data in your unlocked table and you shut down Postgres or restart, for example, then the data will still be there. However, when there's a crash, Postgres will truncate it. And that's in a sense a feature. The reason that it truncates it is because it's not clear what the data is. And so Postgres goes and zips it at the start. Here we have the same pgbench running, but then we kill one of the Postgres processes, don't do this in production. Essentially what you can see here is that after the Postgres server starts again, then the data is gone. So our unlocked tables are reset. As Greg notes here at the end, if your data is temporary or easily replaced, then unlocked tables can be a good fit, but you should treat them as living in a Schrodinger's box. At any moment, your table might have all the rows or none of the rows. Now, there was a Hacker News discussion about this, and there was an interesting point where somebody said, technically, it's not the crash that truncates the data, it's the crash recovery that truncates it. And so if you go in before you start your Postgres again, you can recover your data. Andres Ryan from the Postgres committer team responded here that unlocked table data oftentimes isn't even written to disk. Now, what is on disk after a crash is completely inconsistent. So it could be missing data, it could be old row versions, you just don't know. And so trying to do anything useful with that is not really a good exercise to do because you will be missing a lot of it. And really, you should not have used an unlocked table to begin with if you can't regenerate your data. There was a clarification question here, which is somebody thought unlocked tables meant that don't get wall log and they also don't get stored in the file system. And that's not correct. Unlocked tables are stored in the file system because unlocked tables can be many times the size of memory. And so Postgres needs to reserve space for them. And the main case why they're written out is because there's pressure in shared buffers, but there's not enough space in shared buffers. And so Postgres has to write out something to disk to make space for something else. Or if there's a clean shutdown checkpoint, as seen in Greg's post. Those are the reasons why you may see files on disk, but you just don't know what that state is. And so you shouldn't trust a crashed unlocked table at all. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.